Hey, Kanchan.
Hello, Jan.
How are you today?
Good, thanks. You?
Great stuff. Great.
Looking forward to 2 o'clock?
Yeah, there's quite a bit to cover today, so we shall see.
I will be going in and out of the webinar, but whenever I'm in, I'll be answering questions.
Okay.
Great. So there's a question on the Q&A. I'm not sure what the answer is, and I'm not sure what they mean. Do you perhaps know, Jan?
Yes, we'll certainly do that in the third one.
Okay, great.
Today's
So
third
anonymous
exercise,
attendee, it will be answered in the third one.
Yeah.
Hello. Okay, let's start. Good afternoon, everyone. Hope everyone got a chance to go through the material as well as revise the material from yesterday. Thanks for coming back together, back again today. I think we have a crackerjack of schedule for today, or interesting material. So without further ado, I'm going to hand it over to Dr. Klopper, who's going to take you through the material today. Actually, I need to say one thing. So I'm receiving a lot of emails, and I can't reply to all the emails, but I've replied to some for now. So if you are finding it difficult, you can always come to these sessions and ask the question that you want to ask. Thank you, everyone. Over to you, Jan.
Thank you very much, Kanchu. Can everyone hear me? Maybe just give us a message there. Yeah.
I can hear you.
Great stuff. I'm just going to share the screen. Let's go for desktop 1. Share. And now I've got to make sure everyone can see the screen.
I can see the screen.
Good.
Yeah, good.
Thank you. Good afternoon to everyone. I hope you enjoy the session. We've got 3 exercises to cover, and obviously what I don't want to do is just repeat everything that's in the lectures or in the notes or in the notebooks that you have. So I'm hoping that you've done some of that and that you've at least tried some of the exercises. So as with yesterday, I've got a couple of extra exercises here you would have seen in the exercise file, just to keep this entertaining and another bit of a learning session over and above what you've already had. And in the third exercise set that we're going to do today, data visualization, which I will say is one of the key aspects of data science. We're going to look for some live data on the internet, and I'll show you how to do a little bit of extra work, just getting your data not from your hard drive or not from your Google Drive, but just data from the internet itself. So stay tuned for that third exercise set on data visualization. But here we're going to start with the importing and manipulating tabular data, which is part and parcel of the groundwork that we do in data science. You will get your data from someone or having generated that yourself, and that exists inside of a spreadsheet file. And it's certainly very important for us to know how to work with this kind of data. So the first question that we'll see, that the first exercise, as I said, every now and again, I'm going to pop in something new that won't be in your exercise set. But sometimes you need to bring a company logo or your university's logo or someone's logo into a notebook like this. So the first question here was add an image from the images folder to the text cell below. And one thing that you might have noticed from these notebooks, this is a web page, and you can actually write some HTML code. HTML is hypertext markup language, and that is, one of the markup languages that is used on the internet to generate pages like this. So what we're going to do, in case you need to do that, if you go to your Google Drive, I'm going to go to, let's get rid of Siri there. So in my G Drive, of course, we've got the data science folder, and we've got our images folder. So I'm just going to show you how to do that. So let's just view these, and let's go for this university one. What you want to do, and this is particular to having your image already on your Google Drive, is you're going to right click on that and say get link. So I've just right clicked on that PNG image, that and right down here, you're going to see in this pop-up restricted or anyone with link. So you're going to choose anyone with that link. And then you can just click on this little bitty here that says copy link. And that's it. It is now copied to your clipboard. And if you now go to the exercise that we have to do, we're going to do the following. We're going to do some HTML coding. And HTML coding is all about tags. It's not, what this course is about, but I just want to show you. So there's this keyword in HTML called IMG, that's for image, and then you'll say SRC for source, and then inside of a pair of double quotation quotation marks. That's very important, and that's where we're going to paste this link that we just copied. But you have to change it a little bit. Google doesn't make life very easy for us. If you work with Google Cloud services, you'll also see it's not the easiest thing in the world. What you want to do is just to notice that that link ends with this backslash right there, and everything after that. So the backslash itself and that view, query, USP, equals sharing, all of that has got to go. So you just end before that last backslash. And then this little bit that says file /D with its /. So the file, the /, the D, the /, that also has to disappear. So I'm going to select that and delete that as well. And in its place, you've got to say UC query. So that's the question mark ID equals. So that's the changes you have to make to that text. And then your image will pop up. And then another argument would be width. So let's set the width to 400. So it prints out nicely to the screen, and there's your logo. So if anyone ever wanted to know how to do that, It's best if you just upload the image to your Google Drive. As I said, you right click on it, you go to get link, make very sure that anyone with link can view that, and then click the copy link, which will then allow you to paste that into this HTML code there. And once you've done that, you have to remember just to make these changes. So this will be on the recording. So anyone who's ever wondered how to get those image right inside of your notebook, just as far as a text cell is concerned. The next thing is just the bread and butter stuff. Just to import your...
Sorry, Doctor.
Yeah.
There's a request that you just zoom in on the code to make it a little bit bigger if you're able to do that.
Yeah, we'll do. Now that's as far as it will go. Otherwise, I can't get anything on the screen. So I'm hoping it's okay for everyone. So import NumPy. NumPy as NP. And these are the abbreviations, of course, that you'll see everywhere that we discussed yesterday. And then pandas as PD. So let's just talk about pandas just a little bit. I'm going to probably say these words many times. I hope you have read the notes or watched the videos or worked through the notebooks yourself. So pandas is an enormous package, and really one of the reasons for the successes of the Python language as far as data science is concerned. In other languages, you get a similar sort of approach to this idea of importing data as a data frame. Especially in R, you do that. In Julia as well, you see this idea of data frames. And of course, those two other languages will manipulate the data in a slightly different way. So we'll just shift return, shift enter to run that block of code. And of course, because we haven't run any code, executed any code yet, we're going to have to wait until we've initialized and connected there. Our cell is run. We see a little tick mark there, and everything has worked. Now, this little send symbol in front of something that's called a magic command. And there's a couple of these depending on the coding environment that you use. So if you were to use a different coding environment, such as VS Code, I should say, you're going to have different things that you're able to do. And that is particular to the coding environment. Here we're using a Colab notebook. So it has this load extension, google.colab.data_table. And all that really does is just prints out these tables that we create with code, how to print them out nicely to the screen. The next question was import the drive function from Colab. And of course, this is also specific to these Colabs. If we use another coding environment, we will not make use of a function such as this. And I'm going to show you just how to do that in a second, because there's an extra questions on those as well. But there is this drive function in the Colab module of the Google package itself. And we just import that. Remember, if we import one of the functions in this namespace, this google.colab namespace, we can use that function directly. And then this next exercise, just for you to, of course, just run this line of code. So there's this mount function as far as drive is concerned. So a mount method, I should say. So drive.mount. And we always mount the root of our drive. That means the top level of our drive, and that's called /G drive. And in case you need to run this code again, we always just put this little argument there, force a remount. So it'll just do a clean mounting. And mounting just means it opens it up so that we can read it. So I'm going to click on this. I'm just going to stop sharing my screen because don't want to show my passwords and all of those things. I'm just going to stop for 1 second and I'll see you just now.
Those people who are raising your hand, you can also ask a question in Q&A. It would be impossible for us to, it'll be difficult for us to give you a chance to ask your question verbally. So please do ask your question using the Q&A functionality.
And we're back, and my drive is mounted there, as you can see. And in the next question is just to navigate to. And now the navigation is really going to depend where you save this worksheets, where you save them on your system. And So it might be on your Google Drive, you'll have to put in a different address, but certainly if you put it in the top structure, this is what it's going to do. So the %CD, if everyone has done any work in the terminal or in the command prompt in Windows or the terminal in Mac and Linux, we know CD, well, it also works in the Windows command prompt, yeah. You get the CD command, and that means change directory. And we put a % in front of it, that makes it a magic command. And that allows Python just to interact with your computer system. And in this case, it'll simply be Google's drive that we're working with. So it's /G drive. And this has got to go in a set of quotation marks, of course. And then it'll always be in my drive. And that is where your drive really starts. And then in my case, it's in data science and /data. And this changes the directory just as you would do in your computer, you know, when you have your folder structure open, that you navigate to that folder or directory. And that allows us to be in that directory at the moment, because this data file, data.csv, we know that it exists in the subfolder called data, and that allows us just to import that file. And the question they asked us to assign this object to the computer variable called df. So we'll say df equals, and then inside of pandas, there's the read_csv file that you must know about. And that's going to read a comma-separated values file. Of course, if I just stop here for a moment, you'll see this plethora of arguments that you can set with this read_csv files. And CSV files, depending on how they are saved, can cause quite a bit of problems, and you might have to use some of these arguments. And as you can see, there are apps, you know, there's absolute bundle of them. And now I can just say data.csv. Now, if I didn't change this directory, I would have had to put all of this in front of the data.csv. That would certainly also work and also be possible. But because we changed the directory, we can use this folder, this file name directly. Now, the next question that I've got here is not in your notes set, because I want to show you how to import data, not just from your Google Drive, but in other ways as well. So the next question is import a CSV file from your computer's drive, if you wanted to do that. And one of the best ways I want to show you is if we go to these little less than and greater than symbols there. Remember, we spoke about that yesterday. That gives us a bit of code snippets that Google will add for us. And if we scroll down, sometimes it's a bit difficult to find. Let's see. I think I'm past it already. Download, import from Google Sheets, install. Open files from your local system. There we go. So if I'm going to click on that, it says open files from your local system. And there's the boilerplate code. Boilerplate means it's already written for us. And I'm just going to hit this insert button. And it will open a cell right below the one that we were in at the moment. It was that one, import a CSV file from your local drive. And it'll paste that code in for you so that you don't have to, do all the typing yourself. But we can quickly look through that code. It's also this Google package. It's Colab module. And there's another function in there called files. And it has a method called upload. So it's files.upload. And that's going to upload from your computer to Google's computers so that we can work with this file. And then some hectic code down there that we needn't get into. But if I run this now, we'll see what happens. It'll ask you to choose a file. And if you hit that choose file, we're going to see that our computer's system shows up. And on my desktop, I've got this data.csv file. So I just select that. This is on my internal drive of my computer. This is not on Google. And I'm just going to click open. And you'll see that file now uploads from my hard drive to Google itself. And now I can just make use of that file. And you can see here, it gives me the name there so that I can now directly use that name as we did before, equals pd dot read_csv. So we do exactly the same thing, and we use the file's name that was uploaded. And you might find sometimes, depending on how many times you run this, it might have different names. So you can already see I did this before. So now it's giving me a second name for it because it's the second time I'm actually uploading this file. So that's the name that I'll have to use inside of here to do that. So I hope that was clear enough, but it certainly asked the questions. But that is a very easy way to import your files directly from your internal drive. So if you just go to this little code snippets here, just scroll down until you can find that code snippet that says that you open files from your local system, and just click on that insert button. That code will show up. Click choose files. Your browser system or your file browser system will open up, and you just select the file. As simple as that. The next one is just to import data directly from the internet. So many, and that's what I spoke to you about before. Right at the end of the third exercise file, we're going to import some data from the internet, and we're going to do a bit of plotting and just exploring that data with a tiny little data science project, just exploring that data. So here it says there's this CSV file at this internet URL, https://stats.gov.nz. So that's a New Zealand government website, and they've got the CSV file about our financial year provincial information. And so how would you go about importing that? So what I'm going to do, instead of me having to type all of this, I'm just going to highlight this and copy it so that I can paste it. So that's that whole URL. It's just the HTTPS, so a normal URL that you would type in at the top of your browser window to open a web page. And we're going to do this. The question asks for us to name it PD_online. So that's going to be that. And it's PD.read_CSV. No difference whatsoever. Read_CSV. And then inside of our quotation marks, I'm just going to paste that whole URL in there. And if we look at it now, let's do PD online, and we do the first 5. So I'm just using that shortcuts that you must have seen in the lectures here, in the lectures or on the notes. Indexing into your file is a very important thing to do. So if we do that, it's going to read that CSV file from that New Zealand, from their systems, and there is my data. And it prints out nicely because we use that magic command. There's all our data. So you can take data directly from a website if it's a CSV file. And of course, there are all sorts of other file formats that you can do as well. So that was the 3 ways just to get data into your Python session with Pandas, either from your Google Drive or from your own computer's drive. Or as we can see there, if you have the proper link directly from the internet. Now, the next question was, we're going to go back to our original data frame, and it just asks us to print the first 5 lines to the screen. And remember, there is this head method. So df is our object that now contains our data frame of that data that we imported. The actual content of the data doesn't really matter. And for us and our purposes here, we just need some data. But there is a method, and it is a method because we're calling it on an object. So it looks like a function because there's open and closed set of parentheses there. And but it follows an object. So usually we'd refer to this as a method. So that head function that's going to print out the first 5 observations or first 5 rows in your data. And as you can see there with the index, of course, Python is 0 index. So the first entry is entry number 0, and the second entry is entry number 1. So that's always worthwhile to remember. And you've seen this, you've seen me do this just using the index notation. And remember, index notation is always square brackets, and it's always row, comma, column. So it's all the rows, comma, all the columns. And if you don't put a column, don't put a comma, it's only going to be referring to the rows. And because I want up to row 5, I'm using this syntactic sugar again, just :5, meaning from the start up to number 5. And that's going to do exactly the same as the .head method. I'm getting back exactly the same results. So once data is imported like this, I like to just view the first couple of rows. Remember, there was also, I think in the notes, we also spoke about the tail. And of course, if you do the tail, that's going to give you the last 5. So you can kind of already see that there should be 199. That means 200 rows of data in there. but it's always good just to call the shape attribute. The shape attribute is, and it's an attribute, meaning it describes something about the data frame. It doesn't actually do anything. So there's no open and close parentheses after an attribute. So it's df.shape. And as you can see there, it returns a tuple. And remember what a tuple is. From yesterday, it has a set of parentheses around it, where a Python list has the square brackets and a Python dictionary will have curly braces. This makes it a tuple. And as always, it's rows, comma, columns. So we see indeed there are 200 rows of data, and there are 13 variables. So this object that we can see here, that is a pandas data frame object. So if we can check on that, let's do that. Let's insert a new code cell there. I'm just going to say type. Remember the type function, I'm passing df to that. And of course, we'll see that it is a pandas.core.frame.dataframe object. That is how it's represented internally to Python as an object. But I can reference any of these columns, just that single column, just a single column. And once you just refer to a single column, it is actually a pandas series object. So it changes a little bit. And we are asked here just to get the HR column. And all I have to say is df.hr. And if I do that, that is going to give me a series object. And we know that it's a series object because not only do we get all the HR values down the HR column there, but they also have an index. So it's not just a Python list or a NumPy array or a tuple or anything. It is a series object, a pandas series object, because I still have my list of indices there. And now I think we get to the first sort of exciting part of our week together, and this is how we start to extract some of the data that we have to, if we want to deal with data and we want to examine just a certain bit of the data. So this exercise asked us to just display the HR and SBP columns to the screen. And we don't want to see any of the other columns. We just want to concentrate on these at the moment. And then in the notes, you'll see that it was df.ilock and df.lock. ilock for integer location, where we have to pass the actual value of that column, and it starts at column 0, so column 0, column 1, column 2. But .lock for location means we can actually use the column names. And because we're using indexing, indexing always goes inside of quotation marks, and it's always going to be rows, comma, columns. So immediately always just put my my comma there, so I know that I have rows, comma, columns. So before the comma then is the rows, and what I want is all the rows. And the shortcut syntactic sugar for all of the rows is just a colon symbol, and that just means all rows, please. Comma, the columns that I want, I've got to pass them as a Python list object. And now I can just type the ones that I want as elements in my list object, and it was those two, if I remember, yes, HR and SBP. So it's very simple: row, comma, column. And column, we want more than one column. So if we want more than one column, we've got to pass them as a list, a Python list. And a Python list also goes in the set of square brackets. And that should work. And indeed it does. We can see there our index on the left-hand side, but now we can only see the HR and the SPP column. So that would be exactly what we wanted. This also is a pandas data frame object now. The next question was, what are the sample space elements, unique elements of the column group? And that's very important. Remember, we have numerical data and we have categorical data. And when it comes to categorical data, the statistics around categorical data is all about frequency or counting. How many times in your data set, if you go down all the rows, all the observations, how many times did each of the sample space elements, and in machine learning, we'll call those classes. So those unique elements in the group column, how many did each of them occur? So what is their frequency would be the proper way, I suppose, to ask about that. So first of all, we want to know about the group pandas series. So it's just df.group and unique, there we go. Unique is our method that we're going to use there, and that's going to return for us this array of values. And yeah, indeed, it's an array, and it says active and control. So we can very quickly find out what the sample space elements were the values from which at random every observation could, their value could have been taken from. So you can again think of a little hat, and in this hat will be two pieces of paper, and one says active and control. And when one observation, one of your subjects comes by, whether that be a human being or an animal or something in your lab, they get assigned a random value, and this random value will either be active or control, and you just draw that from a hat. But certainly those are the two values that make up the sample space of this nominal categorical variable, and the way to get to that is just to use the unique. The next question was display the HR values for those who are indicated to be active in the group column using row column indexing. So this is bread and butter stuff. After you've done this a while, this just comes naturally, and this is what you do in data science all the time. I want to select only some of my data based on certain criteria, and I want to meet those. I need to meet those criteria, and I've got to do that. And what I'm going to show you here, there's fortunately and unfortunately, we spoke about this yesterday, more than one way to go about things. So that makes it frustrating in the beginning and a bit confusing, because we all just want one way to do it. And eventually, when you start doing this for yourself, you're going to use the way that just works for you. But I'll show you, of course, a couple of ways. So again, we're going to use the .loc location because that's what we want to do. Square bracket notation. So it's always going to be rows, comma, columns. Now, you don't always have to do the columns. You can only do the rows. So if there's no comma, there'll only be rows, but we certainly want rows and columns here. So we want in the group column only those that have as their random value active. So I've got to do that pandas series df.group, and I'm going to use this double equal symbol because I want to know whether something is true or false. So that would be equal, that would be like the mathematics equal symbol is the left-hand side equal to the right-hand side. So it's double equal symbol and active. So this is as far as the row is concerned. So this whole thing is the row. So it says take my df.group, so go down that column, row by row, and only select those that have active. And those that are not active, remember this comparison is going to return either a true or false value. And only the ones that return a true, row by row, only the ones that return a true are going to be included in this bit of code of ours, or the execution of this code. All the ones that are false will be excluded. So that's my row bit. I'm going down row by row, and then comma, what columns do I want? Well, it asks for the HR column. And if we do that now, we're going to get a pandas series object because we're only looking for one column there, just the HR column. And of course, all these HR values that you're going to see and now are only going to be, and you can see it starts skipping. There's 184, 187, 189, 191. So it's certainly skipping some of them. And that's where we did not have active. So that would be one way to go about it. The other way is to use this idea of series notation. It's going to be exactly the same. So if that first way works for you, because it is sort of the standard way to go about it, don't listen to the rest. Don't get confused with the other ways to do it. So it's still going to be df.group. And I'm going to say equals active. And I'm going to stop there. So there's no comma in there. So I'm not doing rows, comma, columns. And if I have no comma, it's only the rows. So this is going to give me back actually the whole data frame, but only the ones, let me run that code. So it's going to give me back the whole of the data frame, all of the columns, in other words. But when we go to group, you'll see there's only be active right on the right-hand side of the screen. There's only active. That's all there is. So this is now a data frame. And just as with a data frame, I can now just reference one of the columns. So I can put the .hr at the end to refer only to that series, only to that column. And that's going to give me back exactly the same thing. And I'm just going to copy and paste this because you can always use this syntax as well, where you don't use the dot notation, but you just put it inside of a set of square brackets and then inside of quotation marks. And the reason why you would use this and not HR is if you have illegal characters in your column names. So if my column name, for instance, was H space R, if in the spreadsheet file that someone gave you or that you designed yourself, you have these illegal characters in that first row denoting all your column headers, there was an illegal character in there, then I certainly could not say H.R. White space, remember, in Python means something. So this would certainly be impossible. Python wouldn't know what to do with this. So it is in those cases that you have that problem, use this notation. Otherwise, please always design your spreadsheet file so that there are no illegal characters. So it just makes it so much easier when you do the analysis. But this is going to give you exactly the same results. Now we come to things, slightly more realistic even, because we many times we want to be much more granular about how we extract, what data we extract. So this one asks, display the HR values for those in the active group who are 50 and older. So we have two conditionals now. In the active group, in the group column, they have to be active, and in the age column, I think, yeah, it's the age column, they have to be greater than 50 years or older, so that 50 is certainly included. And we're going to make use of some operators, the and or operators, and they're very easy actually to understand because they just do, what it says on the label. And meaning something and something else must be true, or one or the other, or both can be true. So this one's going to be quite easy. It's df.lock as always, square brackets, and let's use this, in this instance, let's use the row comma column notation. So putting my comma there. When it comes to the rows, there are two things that must be met. So what I would usually do is I put my one set of parentheses. You've got to parentheses. I remember that the ampersand symbol is the symbol for and my other set of conditions. So I understand immediately that I want to have both of these conditions met. And we're just going to go down the rows of one of the columns. So let's start with the first one, df.group. And what did we say there? We wanted those to be active. So equals active. So for each of the rows in that group column, it asks, is this one active? Yes or no? True or false? That's what it asks. And the other one that we want df. I think it was age, yeah, greater than or equal to 50. So we've got to put that equal as well. This is the whole conditional, greater than or equal to 50. They've both got to be true. And then, of course, for the column, we only want the HR column. And hopefully I didn't make any small errors there. And there you go. On the left-hand side is all the indices, because this is a Panda series object, because I'm only getting back a single column, just the HR column. And they are all the HR values only for the subjects that had active indicated in their group column, and at the very same time were 50 or older when it comes to the age, column. And then the next one asks that we want to print out more than just that single column. We actually want, I think, yeah, it was two columns. Add the HR value to the display from the above. So that makes it very easy, actually easy question. I'm just going to copy and paste, because in data science, when we have to do a lot of typing, we're lazy and we want to save a bit of time. So we copy and paste a lot. And this time I also want the age column in here. So now I've got to put that as far as the columns that I want. Because I want more than one column, I have to put them in a Python list object, and there's my list with a set of open and closed square parentheses there, square brackets. So that's going to print out both things for me now. And there we go. And that just helps us also quickly look at all the ages down there. You're not going to find an age that is less than 50 in there. They're all going to be older, equal to or older than 50, because we put that as a conditional there. They had to be. And there's an and symbol there, ampersand. So both of these have to return true. So if the participant or the subject wasn't active, but they were 49, they would not have been included, because one of these two conditionals returned a false, and the and very clearly says both have got to return a true value for me, going down the rows. Let's look at the next one. Display the ages and survey choice of those that did not choose 1 and 5. So this comes up surprisingly often in data science, where you have this categorical variable or even a numerical variable when you just want to be above and below a certain age, for instance, or certain value. And as soon as you put some nots in there, you want to exclude something. And it is a situation where the ones that you exclude are actually in the minority. So in the survey column, I think there were values 1, 2, 3, 4, 5. So 1 and 5 is only 2 out of the 5. So that is in the minority. And 5 is quite easy, but sometimes you have a sample space that has got 10 or 20 or more elements in it. And you want just to exclude 2 of them. And that means the inclusion will actually, in case of 20, if you only want to exclude 2 of them, you've got to include 18. So you'll have to write so many of these, conditionals. So it becomes easier to just use the not operator. So you have and or, and then we have the not, where we actually exclude certain things. So that's a very common, well, it's a fairly common scenario where you just want to exclude something. And in the video lectures, I think I use this idea of building your criteria first, just to get them out of the way. And if you've built your criteria like this, it also means that you can use it over and over again. Sometimes there's other parts of the data you want to analyze, but according to these same criteria, using these same conditionals. So save them as a computer variable, and that means you can use them over and over again. So I know it's going to be something, and let's just read this again. Display the ages and survey choices of those that did not choose 1 or 5 in the survey column. So let's just build that. So I'm going to say something or something, because it's 1 or 5. So it's going to be df.survey, and let's make that equal 1 or, and this up, the straight line up and down, for me that would be shift / on my keyboard. You'll have to find it on your keyboard. Sometimes it hides away a bit on certain Windows keyboards. So df.survey equals 5. So I'm including the things that I actually want to exclude. So if they are 1 or they are 5 down that very same column, I'm selecting them at the moment. So I'm purposefully doing exactly the opposite of what I'm asked for, because now I can say df.loc, square bracket notation, put in my comma because it's rows, comma, columns. And what I want now is the criteria, but it's not the criteria. I actually want the absolute opposite of that, and that's the little tilde symbol. So tilde crit means to exactly the opposite of what was asked there. That's the not, we call it the not operator. So not the criteria. So everything but those criteria. And the criteria were select down that survey column the true values for either they having a value of 1 or 5, and those will all be included. They'll all be true, 2, 3, 4, and 5 will be falses. But if I put the not in front of that, it's going to change all the trues to falses and all the false to trues. And thereby, I'm now including the 2, 3s, and 4s. And as I said, it becomes useful if the ones you want to include are actually quite a bit. And then I think we were asked for display the ages and survey choice. So again, comma, the columns, but there's more than one column. So I actually want age and I want survey. So let's do that. And I think that will work. Let's run that. And indeed it does. So if we look down the survey, you're only going to find 2, 3, and 4s in there. You will not find any 1s or 5s in there. Sometimes we just add that as a sanity check just to make sure that our code executed, but we're actually just interested in the other column. But we print that column with our criteria as well, and we can beautifully see here that we'll only find 2, 3s, and 4s in there under the survey column. We definitely will not find. So that's a very useful thing to do, especially if you have this, as I mentioned, many sample space elements or many criteria that you want to fulfill. Just do exactly the opposite thing. Display the age and HR columns for all IT consultants and energy managers. So I think certainly there was a jobs or vocation. Yeah, vocation I think was the column. So we've got to decide. We've got to use something, and the hint is there. The vocations are IT consultant and energy manager. Let's try and build this. And the first thing I'll usually do is I'll create this idea of just including a Python list of these things that I want included. So that's IT. I just want to see consultant. And now spelling and uppercase and lowercase becomes very important. And I just want to use this opportunity clearly just to remind you that that is one of the problems with tidy data. If someone else collected all that data and did all the typing, they'll type yes, 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 and the one yes will have an uppercase Y, and the next subject will have a lowercase y for yes, and an uppercase Y, yes, and a lowercase y, yes. A computer language is going to see those as totally separate things, two different things. So spelling and obviously will make a difference, but uppercase and lowercase also makes a big difference. So energy, let's do energy, and that was a lowercase manager. Should have just copied and pasted. So that's my Python list now, because I'm going to say df.loc, so location, and it's again rows, columns. So let's think about what the rows are going to be. We're going to say df.vocation, go down that column, all the vocation, yeah, it was vocation. And then there's this little is-in method, is-in jobs. And it's almost like a little English sentence there, isn't it? Go down the vocation column and look for all the ones that has this jobs, the values in this jobs are in them. There is in them. Every element is in that row. And then of course we want the age and we want the HR columns. Let's see how that works. Yeah, it works. So we only had 3 results there. And let's just make 100% sure. So let's put the vocation in there as well. Vocation. As I said, this is kind of a sanity check, then you know. And down that vocation column, energy manager, IT consultant, energy manager. So you're not going to find anything else in there. So this is also a very nice way, especially once again, if you have a large set of sample space elements, and there's only a few that you actually want to select. That is in comes to your rescue. So is in is something that you'll use quite often, and I think the next question is exactly the same thing as the counterpart to is in that you'll also use quite often. It just asks for display the data frame object, but only for those that have the term professional in the job title. So you'll get these columns in your data set, and they'll have this long string of values in them. In this instance, it's people's jobs. And the job title, is quite long, and there's this one keyword in that job title. That is what we're after in this instance. So df.loc, and we're going to do, so we want to see this whole data frame. So there's not going to be comma columns. We want to see all of them. So no comma in this instance. But we want to go down the df.vocation column, and then we have this str.contains. So those are just 2 things that stick in your head. Comes from memory, is in and str contains. Those 2, depending on the type of data analysis that you do, becomes very useful. And now you can see the whole data frame is printed out because we didn't have a comma right over there, comma certain columns. We wanted all of the columns, so we don't have to put that. We don't have to put, so for instance, that comma and then all the columns. If we only do rows, you only need to specify these rows, but you see there's the term professional in vocation there, and there's the term professional that comes up inside of there as well. And of course, there's all sorts of things that you can do to make it uppercase, lowercase, and in case, of course, if you're interested in those. Oh, yes, the next question. Yeah, there's a question about that. Create a new column called lowercase, where all letters in the vocation column are turned to lowercase letters. So we've got to create a new column, add a new column to our data frame. They're going to be added to the end, and it's got to be called lowercase. So there we go. So df, you've got to put this in the square brackets and and put quotation marks around it. And we're going to say df.vocation. So that's the column we want to reference. And then str for string, and then lower. Okay, and there we go. I think that's all you need. And let's print out data frame 2 just to the screen, df, and right at the end, We should now have, yeah, there we go. A vocation is now added right to the end. A new column, it's called a lowercase as we specified, and everything was turned to lowercase. And sometimes that's an easy way. In this question here, we might have had professional here with an uppercase P in the first row, and in this row number 187 and 195, we might have had a different, so uppercase and a lowercase P. And one way to quickly solve for that is just, either do upper or lower there, and then but generate a completely new column from that so that you don't overwrite the column that already exists, and then select from those, because everything is now lowercase and you won't have this issue of uppercase and lowercase. There we go. Oh, that was actually the question there. And for us to display that new column, so df.lowercase, we did not put any illegal characters in there, so we can use the dot notation. And there we go. We have a pandas series object, and everything is now lowercase. So just a bit of bonus quickly here for this video. This will also not be in your data set. Now, this line of code here, if you use a MacBook or anything with a high DPI display, and that's just a little magic command that I always write. Otherwise, the plots tend to come out a little bit fuzzy on a high DPI display, so don't worry too much about that. What I wanted to show you here is the third session today is going to be about plotting, but pandas, if you didn't know, includes a bit of plotting as well. It's not the greatest, I would say. It's not something that I use often, but I just wanted to show you it does exist. You can actually plot straight out of pandas. And so df.age, as you can see there, so that's going to be the age column. So that returns for me a pandas series object dot plot. And I have to give it a couple of arguments here, keyword arguments. Kind equals hist, so that's going to give me a histogram. And orientation is going to be horizontal. And that's semicolon. I'm not going to put the semicolon there. I'll just show you what happens if you don't put the semicolon. There we go. We get a horizontal histogram, for instance, but it prints out a little bit of information about, which is a bit ugly sometimes. You don't want that in the report. And what you can do is just put the semicolon, of course. And now with the semicolon gone, that's what you get, a horizontal histogram. Then other ways to go about it as well. You get df.age. So again, just that pandas series .plot.hist. So you don't have to put the kind equals hist as an argument. You can just say .plot.hist. Color is K. K is the key color, which is black. Alpha means it's transparency. We're setting that to 50% transparency using the fraction 0.5. And fig size is how big the figure is going to be in inches when you print it out, actually, and we pass that as a tuple. That's the width, comma, the height. And again, just the semicolon, so we don't see that. And you have a histogram upright, and it's black, but it's 50% gray, 50% transparency, so that makes it a little gray. Here is very quickly a box and whisker plot. So the third module is going to be about plotting, but just to show you here quickly, we can create a box and whisker plot straight from pandas. So we didn't use any plotting library, just come straight out of pandas. So .plot.box, and there's a color argument, and I'm passing a Python dictionary to this color argument. I'm saying make the boxes Dodger blue. That's the blue that you see there, and make the whiskers dark orange. And those are the whiskers there. So all sorts of things that you can set. Here very quickly, right at the end, let's just create a little bit of a scatter plot quickly. So df.plot.scatter. And now I'm saying what I want on my x-axis and what I want on my y-axis. So it's age versus SPP. So that's a quick little scatter plot. So that's it for pandas. Now, I think you can do a whole semester course just on pandas, and even that won't be enough. So certainly this little bit that we've done here is not nearly enough, but I think that gives you a good idea of the basics. Watch the video lecture again, play around with a notebook and do these exercises again. And you'll refer back to them as you start, but very soon you'll spread your wings and go beyond just then the notes for this course. Just go online very quickly to find the answer to how to extract certain data, how to manipulate, clean up your data, because we mentioned yesterday, a lot of your time is going to be spent up on cleaning your data. Don't bother cleaning it up inside of your Excel spreadsheet. Just clean them up with some pandas code. In the end, you'll work with a certain kind of data all the time, and there'll be the same sort of errors in every data set, and you'll find the solution how to fix that in your case. And none of this will take you will take you particularly long to do. So I'm going to save this. I'm going to close it up, and unless Concha or Emil want to say something, I'll go on quickly to the next module, which is all about summary statistics.
Great, thank you, Jan. I just want to say that, sometimes it might help for you to look at the Q&A screen to see if your question's been asked before. That is if you're not getting the answer in quick time. Yeah, that's all. Emil?
No, all good. Going strong.
Great. All of you should have gotten an invite for 6 p.m. on Thursday. Please note, it's not a compulsory session. It's just one of my former students who graduated with his master's earlier this month, talking about his career in data science. And it'll give us a chance for you to ask any questions with regards to further courses, with regards to postgraduate studies or undergraduate studies or whatever you may want to ask to further your knowledge. Right. So that's for 6 p.m. Please don't feel you have to come. Oh, by the way, every time you get a Zoom reminder that that there's a Zoom session happening, that is not from me, but rather it comes from Zoom itself. So you don't have to email me and thank me, but thanks for thinking about me. Okay, I'm going to stop right there.
One more comment from my side. I do give quite a lot of answers of trying to say Google it, and please don't get annoyed with me on that. It's just, as we've been saying, big part of coding is not to remember every single little aspect. I'm sure Dr. Johan doesn't even remember every single part of this code. He probably remembers a lot more than I do, but most of us are constantly Googling to try and find stuff out. So yeah, I'm pasting links for everyone. There's a lot of websites, so please don't hate me for that. It's just part of coding.
Well, that's a good point, Emil, in that, you also have to learn to Google and find the answer. So it's a good thing he's telling you to go and Google or search on Google to find the answers. Right. Cool.
I'm just, thank you very much for those two comments. I'm going to, underline that and color it in with a yellow highlighter, because no matter how long you've been coding, part of data science is Googling. It's part of the job. They go together. Unless you do a very repetitive task in some company, and that's what you do every day, the same thing. And it's also a way, you also have to learn how to find the exact solution, because you are going to find solutions that are not going to work for you. And go to page number 2 and go to page number 3. Eventually, the answer will be there. And that is part of the beauty of this whole data science community and the Python community is there is no question for which there will not be an answer. You will find an answer. So summary statistics. I mentioned yesterday for me, one of the beauty of—
Jan,
yeah?
just last comment before you start. Sorry about that. Somebody asked me about the 6 p.m., the link for the 6 p.m. Webinar. You should have received an email. If you haven't received the email, don't worry about it. Zoom will send you an email a day before the webinar, as well as 1 hour before the webinar. Even if that doesn't work, it should be the same link as it is for this webinar. Thank you. Sorry, Jan. Carry on.
There we go. So yesterday I said one of the beauties of data science for me is teasing the story that data wants to tell, that data wants to tell me, to tease that story from the data. I think that's the, and to suddenly see that solution come out, to be involved with a research project, and we're not quite sure, and tomorrow certainly we're going to talk about this idea of hypothesis testing, and our null hypothesis is there's no difference, but as researchers, that was our research question. We think there is a difference here. And we know that answer is hidden in that's the story is inside of that data. We just have to bring it out. And when that solution comes out and we're amazed by those results and we reject our null hypothesis, we accept our alternative hypothesis, or even when we fail to reject our null hypothesis, it's very exciting stuff. And so one of the 2 major ways of starting to understand the story that the data is trying to tell you is to summarize it and to visualize it. So these are 2 very important steps. And no matter what kind of highfalutin, difficult analysis you do, I urge you always never to omit these 2 steps. Start to understand your data first. And as I said before, probably said in the video lectures, is that we can't stare at a big spreadsheet and understand what the data is trying to tell us. We, as human beings, we have to summarize that. So that's what descriptive statistics or data summaries are all about. And in many instances, that is all you do. Many people have built large research careers, publish a lot of papers, especially in my field when it comes to trauma surgery. You'll see that in trauma surgery, many papers are all just about descriptive statistics. There's no deeper analysis being done on that data. Just describing the data is, in some fields, is very important and very informative. So question number one there, I'm just going to run that. And I'm going to say once again, if you use a Jupyter notebook outside of this Google environment, don't run this line of code. You don't have to do that. And of course, if you have Python installed on your local system, you're running your local system, your data is on your local system, don't worry about the drive and obviously connecting to your drive. I mean, that's superfluous for me to say. I apologize for that, but you don't have to do any of this Google stuff. This pertains to Google Colab. So we have to import pandas as PD. And we're going to import NumPy as well. Import NumPy as NP. There we go. No problems there. Import the stats module from SciPy. So from, let's do that. From SciPy import stats. I can type from SciPy import stats. So stats is a module. There's a couple of modules inside the scientific Python package. And in that stats module, there's a bunch of sub-modules. We actually saw it when we did the geometric mean yesterday. But the stats module has a bunch of functions inside of it. So SciPy is also one of those enormous. And we've just had the end of the yearly SciPy conference, SciPy 2021. Next year, there's a couple of conferences, and now these days they're all online. The majority of them are free of charge. So there is a SciPy conference every year. Very important because there's lots of topics in. By the way, you can watch all the conference videos. You can watch them on YouTube. These big conferences in Python, invariably, most of these big conferences after the conference or even minutes after, there's been a meeting at the conference, it'll go out on YouTube. The Python conference community, even in the days when we were able to fly and attend these conferences, they always came out on YouTube so that the whole community can see these proceedings of these conferences. So it's just been SciPy. And the other big one, and you can go search for that on YouTube, is PyData, P-Y-D-A-T-A. So PyData is also used to be very, very big conferences, and certainly you'll find all the old PyData conferences. Just to mention also this Colab, as you know by now, it's built on what is called a Jupyter notebook, and there's a JupyterCon conference every year as well. This year I was fortunate to do the opening keynote address on that, which you can also find online. And I used that opportunity to push our own local agenda, our country's agenda, our continent's agenda, and starting, showing leadership and showing the way, showing the rest of the world how we can use data to solve problems. So remember those two, SciPy and PyData. Those are big conferences every year. Go watch all those. Immediately after this, go watch a few of those presentations at these big conferences. So the data that we're going to use is again just hidden on saved on our Google Drive. So we're going to do from Google.colab or Drive. That would be that one. And then obviously we've got to sign into our Google Drive again. So we've imported this function now and it asks us to sign into our Google Drive. So Drive, I suppose I should have done this beforehand, google.mount, of course. And what I want to mount is always my G Drive. So I'm going to run the cell. So I'm just going to stop here quickly. And there I've mounted. And now I just want to change my directory. So remember, that's our magic command CD for change directory. It's got to go inside of notations, and we're going to do to our root directory, and then where all our stuff is actually hidden, and there's a space between the my and my drive, and that's also a good reason why this has to go as a Python string, so that that white space can not cause, it won't cause any problems. If you don't use this, there's something called escape characters that you can look up. And I think, yeah, that is where it is. We change directory. And of course, then we have to assign or import our spreadsheet file, our CSV file, as a data frame object. So we're going to do pd.read CSV as always. And our file that we're going to work with, and this one is called client data.csv. So a bit of different data to have a look at. Once again, you can see the pop-up there of all the different arguments that exist, depending on how difficult these CSV files have been saved. And there we go. Let's see that they're all there. It asks us to display the last 5 rows. So I'm going to use the .tail method. So df.tail, and it seems to be all there, and there seems to be 1,000 of them. Let's just use this opportunity just to do df.shape, just so that we know the shape attribute, remember, and that's going to show us that we have 1,000 data points, so 1,000 observations, or 1,000 data on 1,000 subjects, and we have 11 variables. So what are the sample space elements in the home loan column? df.homeloan, and I can use the dot notation because I don't have any illegal characters. The space was taken up by underscore in the spreadsheet file, and as I say, always do that. It makes it so much easier, more pleasant to code. And what we want here is the unique method, and we see down the home loan column there's only true or false, so they either had a home loan or they did not have a home loan. Of course, to do the frequency, there are more than one ways to do this, but my favorite is just going to be home loan. So df.homeloan, home loan, and then dot value counts. So value counts, there we go. And that's immediately going to give us this little series object, in as much as we have as our index the sample space elements that are false and true, and we have this the frequency of each. And when it comes to categorical variables such as this, a nominal categorical variable, because we can't put true or false in any kind of natural order by logically arguing the point. So there's true and there's false, and there's 515 of one and 400 of 85. When we come to Friday, we do a bit of machine learning. This becomes very important, in as much as this is going to be a target variable for us, for instance, and we have to know that we have relatively equal frequencies of each. Otherwise, we have what we call imbalanced data sets. So we have imbalance in our classes, but you have 515, 485. It's sort of close enough to each other, so that doesn't matter. Sometimes you're just giving this notebook to someone else to write a report, and they don't want to know the frequency, they just want to know the percentages. So expressed above as a percentage, df.home underscore loan. We're still going to have the value counts, remember, as our method. And we're going to pass one of our arguments, which is normalize, and we set that to true. So remember what the normalize is going to do. It adds 515 to 485. That gives us 1,000. So it'll do 515 divided by 1,000 and 485 divided by 1,000. But that'll give us a fraction on the interval from 0 to 1. So if we multiply that by each one of those values by 100, we'll see it's 51.5%, of course, and 48.5. And because we had 1,000, you could have just done that just by looking at the values. But sometimes, as I said, you want to give this research report to someone else who's actually typing up the report, and all they want to type in there is the percentages, and that would be an easy way just to express that for them. Contingency tables, and the reason why even though the spelling is horrible there for contingency, is why I want to bring it in, is that we are going to look at the chi-square test for independence. A chi-square test is something that we also do very commonly. And to conduct a chi-square test, we want these contingency tables of observed values. And with that, we just have along the horizontal axis and along the vertical axis, we have two categorical variables, they're sample space elements, and we just count how many of those occurred for the combination of those. So it's pd.crosstab. Crosstab is the function that I use quite often, and now I just want to state the two. And let me just see, the question asks for children and home loan. So that's going to be df.children and comma df.home loan. So let's have a look at this. So we see for the children in this data set, couples had 0 children, 1 child, 2 children, 3 children, and 4 children. And they had either did not have a home loan or they had a home loan. So we can see these intersection of these two categorical variables. So if they didn't have a home loan, 100 of them without a home loan had 0 children. 91 who did not have a home loan had 1 child, etc. So these contingency tables is what we use when we do a chi-square test for analysis. And the next question, another place other than Googling where to find the solution, of course, there's documentation built right inside of Python as well. And we get to those just using the question mark. So question mark pd.crosstab. So if we do that, it should print out on the right-hand side for us all the documentation on that. And sometimes, you know, you don't have to Google it. You remember, sort of remember how to do it. You just forgot, what was that one keyword argument again? Oh, yes, it was margins. That's the one I was looking for. So that very quickly brings up the help section here for us to just get to the answer quickly. Yeah, I think this next one was add margins to the title. Exactly. So that's pd.crosstab, and we're going to have df.children and df.homeloan, and that was margins. And sometimes you make that mistake, you only put margin instead of margins. And of course, as we type here, as we've seen before with the read_CSV, all these arguments do pop up for this, and all this information pops up, and eventually you start to understand how these things are written. They're not always written in the best way because they sometimes a bit difficult to read, but eventually they become easier to read. And there we go. So the margins are just going to total the rows and columns for us. So when it comes to 0 children, there was 182. So there's 182, 91 plus 103 is 194. So you can see how many of these subjects in our data set had 0 children, 1 child, 2 children, etc. And as far as that home loans, 515 again without a home loan, 485 with a home loan. Next question, what is the average savings? So that's very easy. Average, that's just the mean. Add all of them, divide by how many there are. Of course, this becomes very, very easy. So savings, I think is, yeah, savings is the column header. So df.savings, that gives us a pandas series object. So just one column of values. And what we want to call is the mean method. So very important to understand, I think, what is going on here. So what you are saying just in that first part is just give me that single column. On that single column of values, do something for me. And we just add dot something, dot something, dot something. But here we just want the mean. So we're just going to get the mean of our savings, and we see it's 30,000 odd savings. Now, that's also, you know, when you give this notebook to someone else, you might not want to see all these decimal values. So that question there is show the average value for the savings variable for each, or at least show, I read the wrong question. Show the average value for the savings variable for each of the groups in the home loan variable. So that becomes very easy or very important. So let's do df.log. So we've got to make some decisions again here. So we're back to where we were before. And so what we want, let me just hide that so I can read the question again. Show the average value for the savings variable for each in the home home loan. So that's going to be df.group by, and we want to group by the home loan. And then we want to look at the savings. Once again, there's two ways that I can go about this. I can just say dot savings because there's no illegal character in there. Of course, I could just go the square brackets and the set of parentheses savings. And what I want from this is just the mean. So dot mean. There we go. That should work. And now it's done that group by for us. Probably of all these methods in pandas, this is the one that I probably use most often is group by. So we're going to group by the sample space elements of one of our categorical variables. And our categorical variable home loan here had false and true in it as its sample space elements, and we're just going to average the savings for each of those. And in this data set, we see that those with a home loan actually had less savings. And here's the one I say I read before: display only 2 decimal values in the calculation above. Because sometimes people are just lazy to do that round off. You know, that's a 5 there, so that'll be a 1 there, and that's an 8 there, so that'll become a 7. Well, you can just do it, I suppose, just with a line of code. And the easiest way, there are more than one ways, I'm sure, but the easiest way is just to use the numpy round function. And it takes this thing that you want to round, comma, how many decimal places you want. So there's a decimals equals, and I'm going to set decimals equals 2. But this thing that I want rounded is this whole thing. So I'm just going to copy and paste that right in there as the first argument. And now we're going to see just the 2 decimal places, 0.81 and 0.77, as we had suspected before. So what are the median savings for those 50 and over with no children? Again, we're getting to this idea of, and I suppose I put these questions in here so that it's just a repetitive, because this is something that is so common to do. So I've got 2 things that have to be true. So first of all, I'm going to go .loc, and I've got to do rows and columns. Now, because in the end, we want a savings column. So let's put it there and put it out there right at the start. So we're looking for the savings column, and we want the median of that, so .median. So that takes care of the column that I want, but now I have these conditionals as far as going down the 2 rows, and there's 2 conditionals. So I'm going to put my parentheses, comma, my other ampersand, and my other parentheses. So this one, I want df, let's have a look at it. Age over age more than 50, so that's .age, and those over 50. So what is the median savings of those 50 and over? So it's greater than and equal to 50, so that 50 is definitely included, and with no children. So df.children children equals 0. And again, go down the savings column for me then and just print out the median for those. So we're going to see the median savings, and I hope you get the same answer as I do with 30,000 there. What is the median savings of those 50 and older with children? So what we want to do here is to exclude those that have no children. So we looked before we looked at using the not, so building the criteria, but building in the not. I think what I want to show you here is just something slightly different. So we're going to do df.lock. And in the end, remember, we still want the comma column. So we want the savings column, and we want to call the median on that. So we take care of that bit. And now when it comes to these rows, again, we want 2 criteria, and they both have to be true. So that's going to be ampersand. And so they've got to be those 50 and over. So that's going to be df.age greater than or equal to 50. And now we've got to think of this other one. And this is the other thing that I wanted to show you, another way to do exclusion. So df.children, remember, now I'm just going to say not equal to. So that exclamation mark equals means not equal to, and I don't want it equal to 0. So instead of building the exclusion criteria that we had in the previous module, this is one other way to go about it, and that's going to give me the result there, 30,182.12, if you did the round off there. So calculate the variance in the savings for all the sample space elements of the invest column of those younger than 50. So now it's a little bit different, the other way around. Calculate the variance in savings for all the sample space elements of the invest column for those younger than 50. So we have this invest column. It is nominal categorical in nature, and we want to do that according to what these values are. So first of all, what this question is asking us is just to extract all those that are less than 50. So let's do part first. So it's df.loc, and what we're going to do is df.age, and we're going to say less than 50. So that's what we're extracting now. So I've built this new data frame, and it now only includes those younger than 50. And now that I've excluded everyone 50 and older, now I can say do the group by. And we want to group by all those elements that we have, the classes in the invest column. And now we want from that, we want only the savings column. And for that, we want the variance. So I must confess that this is sort of one of the longest sort of extraction and manipulation of data that you'll do. It's not the easiest. And this is one that might cause a bit of confusion because you're putting the group by a little bit later. And you have age, and you have invest, and you have savings, and you want the variance of all of that. But if you just extract it just with a bit of logical thinking, so what we asked is everyone younger than 50? So just create that data frame. This is that part is going to create a data frame for us, and it'll only include those that are less than 50. And once we have that, let's group by the invest column, and let's look at the savings column and get the variance of that savings column. Great stuff. Show the full values and not scientific notation. So I'm going to show you something here that sometimes work, and it just depends on how large these values are, because what we could see there is scientific notation, 2.139 times 10 to the power 7. That's what this would be, and depending on whether you work with scientific notation every day, that might not be the easiest thing to see that's should be 21 million. So there's one way to go about that. I'm just going to copy all of this. And as I said, this is just a little shortcut. Depending on the size of the value, it doesn't always work. So I would put a dot round at the end. And when you do that, now you can see, now it's easier to see that we have the 21,391,179 there. So if the values get too large, like this is times 10 to the power 17, this is not going to work for you. But usually in the values that we care about, if you just put the dot round there, that's going to work for you. And what I've put here in the tip here, so these notes will also be made available to you, don't worry. But I'm just showing you there a little bit of a different way to go about it. And then lastly, calculate the quartile values of savings for each of the home loan groups. Now we can go for df.group by directly because we weren't asked to necessarily exclude anyone. So we're going to go the whole data frame. We're going to group by the home loan. We're going to group by the home loan. We're going to say dot savings. That's the one we're interested in. I'm using dot here. And then the quantile function. So instead of dot var or dot mean, there's also the dot quantile. And we just have to say which of these quartiles we want. We want the 0.25. The question asks for each of the quartiles. That's the first quartile. That's the second one of the median. And that's the third quartile. Remember, the first quartile, that'll be the value for which a quarter of the values are less than, then the median, and then the third quartile. And that should work. And then we see for both those with the home loan and without the home loan, we see the 3 quartile values for each of those. And that is summary or descriptive statistics. And sometimes, as I mentioned, this is all you're going to do. And this is the work that you're going to present, just summarizing the data. And if you look at your data set, which we didn't do here properly, we're just using a bunch of values just for us to get used to the code or at least see what is available. It's the best, to be together with the data visualization, it's the best way to start to understand what the data is trying to tell us. So let's do file and save. That's it, and let's close that one. So I think we should just jump into this third one because it's already 3:20. And this for me is always one of the more exciting things to get to do, and that is data visualization. So I think right in the beginning when we had our Monday morning session, someone was asking about, we're doing the Plotly library here because there certainly are many libraries. The one of my favorites is the Plotly library, which you would have seen in the notes and in the lecture series, because Plotly is inherently interactive. And if you've run those notebooks yourself and you hovered over those plots, you'll know exactly what I'm talking about. And you can export those, as I mentioned before, and just put them as static images in your reports, etc. So they're actually quite wonderful to use. There are a couple of other libraries that I just want to take the time to mention to you. The one is Seaborn. It's S-E-A-B-O-R-N, Seaborn. And that sits actually, sits on top of matplotlib, which I'll talk about shortly. And that is a plotting library that is basically for data science and statistical time plots. So it certainly can't do all different plot types. It's not that large of a library, but what it can do is geared towards data science. And so Seaborn is one that I would recommend that you look at. The last one, or the second last one that I want to mention, is called Bokeh or Bokeh, B-O-K-E-H. The pronunciation varies. And that is also a sort of semi-interactive and can be very interactive. It has a very steep learning curve, though, quite a difficult library. And then, of course, there's what I would term the grandparent of all plotting libraries, the biggest of them all, the one that can do everything. And it is absolutely enormous plotting package. And because of its size and what it can do, it's a very, very complicated plotting library. So it's certainly something I would reckon it's even bigger than pandas. It is just absolutely enormous. And I'm going to refer you to this video that I made just last week. Or yeah, I posted it there on the 23rd. So on my YouTube channel, I've got this video which is squeeze as much matplotlib into 80 minutes as possible. That's the thumbnail. So if your job or the work that you do really requires matplotlib, there's an 80-minute jam-packed tutorial that you can watch there. And of course, there are many other tutorials that you'll find out on that you can go out and discover. But I made the effort just to add to this course by making this jam-packed 80-minute session just on matplotlib. Back to our data visualization, because as mentioned, we're going to use Plotly. Just search for Plotly, P-L-O-T-L-Y. I think it is in the notes for you to click on. Go to their website, because they've got a very, as far as I'm concerned, at least a very friendly website. And that website just very quickly shows you how to generate plots. Whereas the matplotlib, their documentation is very difficult to read, and it takes time and effort, and that's why I jam-packed that YouTube tutorial just with as much information as possible. It's data visualization. The first exercise there is just to run that cell. Once again, this pertains to people with high DPI displays, just so that you don't get fuzzy plots. They print nice and crisp, print out nice and crisp to the screen. And then just to have our data from our data frame properly. And the video lectures, please go for data visualization, please watch those video lectures, because there are two main bits. They're actually more than just the two, but the two main modules inside of Plotly are graph_objects and Express. Express came a bit later when Plotly, first couple of years of the existence of Plotly, they certainly didn't have the Express, and the Express was really designed to work together with pandas. So it just makes it easier to plot directly. Once you have a data frame object, it makes it a bit easier to use Plotly using this Express module. But the grandparent, once again, if I can use that term, when it comes to Plotly, is the graph_objects, and the Go or PX Express. Those would be in the video lecture. I talk about the different defaults. Some people used to like to use a dark theme for their computers, and if the dark theme, which you can set here in Google Colab as well, you can absolutely use a dark theme. You want the plots to print out not as these white plots that out so badly on this nice dark background. You can set your default to be dark, for instance, then your plots really look good. And for the majority of the time, I do enjoy coding, setting up a dark theme as opposed to this very bright white theme. So let's run that code cell as well, and it's going to import and run everything for us just to save a bit. Why I don't want you to type that, I'm not quite sure, because now in the next question I'm going to ask you to import pandas as PD. So there we go, pandas as PD. Remember with the drive as well, suppose the more you type this, the more it just becomes stuck in your mind. So that's google.colab. I'm going to import the drive function. And now once again, I'll have to mount my drive. So you're going to excuse me while I do that quickly. And there we go. Apologies for that. I don't know why that got stuck a bit. And then as always, we're going to navigate and to the directory that holds all our data. So that's going to be %cd, of course, always in quotation marks, /G drive, /my drive. And in my instance, data space science, /data. Let's hope I didn't make, oops, yes, I made a spelling mistake there, G drive. There we go. And my alt abilities to type are really limited. df equals pd.readcsv. And the data set that we're going to work with here is some crops, some data from crops, crops.csv. There we go. And we asked to do the first 5 rows, and it's always just a sanity check. So let's use .head this time. And we look at that first 5 rows of data, and we're kind of fairly happy that our data imported properly. Next question, the info method. So that's one we haven't seen in this exercise set before, but probably the one that I would use most often is just use this info method on my data frame. We don't make particular note at this time of all the missing values, but certainly that's one of the columns that I would look most often. Is there any missing data? And then very importantly, what the data type is. Because as we will see, the data type determines what kind of analysis we can do. There's certain tests that we do on floating point values, that will be continuous numerical values, and there's certain tests that we do on categorical variables, which are objects. So it's important for us to know what these are. So add a column called cost, and that is something that you'll also do quite often. So let's do df.cost. And the thing that you have to do is just create a new variable based on values in some of your other columns in your data set, in your data frame. So it just wants us to add those 2 costs that are on the data set. That is the cultivation cost. So df.cultivation cost plus df. What's the other one? Production cost. Production cost. There we go. And then that's going to give us this, this new column. And you can just do that. And sometimes you want to express things in a different unit, and you just do unit conversions. It's very easy to add just new columns and just do some manipulation of the data, just transform the data that you already have. By the way, this is going to be the session at the end. We're just going to look at some data. I'm going to show you a website of open data all over the African continent, all in one website. And there's certainly some interesting data there. And I'm going to show you just to import that, and we're going to visualize and explore. Let's take a couple of minutes and explore that. So that'll be at the end of this exercise session. So the next question is calculate the frequency of each sample space element of the crop variable. And this is unfortunately what you have to go through if you want to do bar plots. A bar plot from the lecture series, remember, that is a type of frequency chart where we count, we show visually the count or the frequency of sample space elements for a variable. So let's just do then df.crop.value counts. And remember, that's going to give us the sample space elements and show us the frequency with which they occurred down that column. So we see the different crops there: cotton, sugarcane, wheat, etc. Because what we are interested when we do a bar plot, the height of the bars have got to be these values, 5, 5, 5, 4, and 4 in the end. So there are different ways to go about that. But for me, I always save that separately as a computer variable. So what we're going to do here, I'm going to call it totals, which is just one of the computer variable names that I use often because this makes sense to me. Dot the crop, dot the value counts. So exactly what we had before, what we want, but then we want not this series object, because that's what we have here. We have this as an index, all the actual sample space elements and the counts. What we want is only the counts. We don't want all these names as well. So to do that, we call the dot values attribute. And that returns for us from this only these values, 5, 5, 5, 4. But we want them in a specific Python format. And what we want is a list, a Python list object. So after the values comes toList, and that's actually a method. So it's not an attribute. So it gets its little set of parentheses. And now I only have those totals. Let's actually print them to the screen. Totals. There we go. And you'll see now I've got a Python list 555, all the 5s and 4. And now I actually want all these elements. And this, as I said, is now a pandas series object, which makes this the index. So it's always with a series object on the left-hand side, it's always the index. And on the right-hand side is actually just that single column. And in this instance, it's just this count, this frequency. And because I use R a lot, and R, we call those sample space elements levels. So for some reason that's stuck in my head. So I always use the computer variable name levels for that. So that's going to be the crop once again. We're going to do the value counts. And this time we are not interested in the values, but we're interested in the index. And that index, we also want to convert that to a list. And now if we do levels, we print them out, that's going to take those indices and generate for me. Let's see who can find my mistake. Value counts, of course, is a method, so it has to have its set of parentheses. Now I have a Python list of those two. And what you have to do is just a little bit of a sanity check just to make sure that the order of these things stayed intact, because you don't want different numbers associated with different elements here. But we see it's the goes to sugarcane wheat in the end and cotton sugarcane wheat in the end there. So certainly no problem came up for us there. So enter your solution here, create a bar plot to visualize the number of instances of each of these crops. So that is just a bar chart. It is a frequency chart for categorical variables. And we're going to use the graph objects. So first of all, you can give your figure a name. And I tend to do that. I give them names because later on I might want to just reuse them and just make a small little changes to them. So this would be very common for me to do, is to assign my plots to a computer variable name. So in this time, it's about the crops themselves. So I'm going to say crop underscore fig, kind of makes sense to me. And it's the go.figure object, the go.figure object. Now I have that empty object. It's this empty canvas. And on top of this empty canvas, we're going to put an actual plot. And that we can put different objects on that empty canvas, and we do that by adding traces. So in Plotly speak, and all these packages have got different names for them in Plotly, that's called a trace, all these specific things that we put onto this blank canvas. So I've got to call my figure object now, which I've called crop underscore fig, and I'm doing the add trace. And you can add many traces. So the trace that I want to add in this instance is a bar chart, and that's graph objects go.bar. And on my bar chart, I want to do the following. On X, I want the levels. On my X-axis, those sample space elements. And on my Y, I want the totals. Totals, can I spell that correctly? Totals, yes. And add appropriate titles and axes labels. Okay, so it's a bit of additional typing here. And directly after this trace, we can put a dot. And what this dot does, it just starts to chain things together as I add them to my plot. And it's update layout is the value that we use there. and the function or the method, and we can add a title. So I'm going to say title equal, let's say, count of crop types. Suppose that's a good one. And on my x-axis, I need a dictionary, because there's lots of things that you can put on the x-axis. You can change the font size, the font type, and all of these things you can add as key value pairs. So the title, I'm going to assign the title to crop type. I'm going to put crop type there. And on my y-axis, also a dictionary. It's also going to be a title. And let's put the word, just put the word count in there. Let's see what that gives us. There we go. And Plotly is going to do all that for us. You see this little angle that it put to everything, so it's not plotted over each other. And of course, we have this interactivity where we can download this as a PNG, we can zoom in, we can pan around, we can do a selection, we can do a lasso selection, and when things get out of hand, we can just come back to reset axis. So it's a really nice type of plot. And if we hover over this, by the way, these tooltips that appear on the top there, you can actually write code to tell Plotly what to put on the little tooltips that show up as you hover over these. So, you know, it becomes very, very powerful. So the next one, create a histogram using graph objects module of the cost variable created above, add an appropriate title and axis labels. So this is just a bunch of typing. Let's just go for it. One more. I think if this gets too many, I think we'll run into fatigue. By the way, what you see me do here might be a point of interest. I do my open close parentheses and I immediately hit return. So it goes to a new line, but it does that indentation for me. And I think this time we were asked for a histogram. So let me just do that. We were asked for histogram and we want our x-axis to be cost. I think, yeah, we said cost. And when to do this kind of indentation and put every one of your arguments on a different line, that is something that you'll see some people do. If it's a long section of code in a code cell, I like to do that. It's just so that when I scroll past this code, it's very easy to pick up what I was trying to do. It's not hidden in this long line of code with argument, comma, argument, comma, argument, comma, argument. They're each sort of on their own line. And Python obviously allows us to do that. And it just makes for me, when I share this code with someone else who's also looking at my code, or I have to look at this code again, it's just an easier way to pick up everything, what you're trying to do. If you just put all of your arguments on a single line. So I think let's do total cost there. And on my x-axis, I'm going to do a dictionary, and it's going to be title. And on my x-axis, of course, now I have cost. And on my y-axis, I do have, let's put title again. And on my y-axis, this time, instead of count, let's put frequency. There we go, that should work. And now we see this histogram. And so what it does, it's a continuous numerical variable. And in the notes and in the lectures, I make this distinction. For now, if you do read a journal, you'll instantly recognize the difference between when you're talking about categorical variables and a continuous numerical variable, because with this type of bar plot, there's no gaps in between, and that's a visual indication that my x-axis here is a continuum, a continuous numerical variable. So cost means money, and it's a continuum, whereas in this instance, my x-axis is a categorical variable. These are unique, discrete values. There's nothing in between, and visually, you know, we distinguish a bar plot from a histogram by the fact that there's gaps in between the bar plot, and there's no gaps in between these bars when it comes to histograms. So in case you were wondering about that. So the next one, create the same histogram as above, but set the number of bins to 14 and the opacity to 0.75. I think what I'm going to do in that instance is to skip that, because it really is just in the notes, and it's just a bunch. Of typing. And what I'm going to do instead is go to this bonus material, because it's really getting late. So the rest of those questions, they are in the solution set. You can certainly just have a look at those. So let's look at this bonus material. Explore Africa Open Data. So this is the website, and it's called Open Africa. And it's this collaboration between many independent data repositories and this organization, Open Africa, for countries all over Africa to put the governmental and other kind of data online and available for us all to use as data scientists or the interested public or whatever the case might be. And you can look at the different data sets. If you click on data sets there above, it's going to give you a list of thousands of data sets, the organizations that belong to Open Africa or organizations on the African continent that actually contribute to this open data, the groups. You can read a little bit more. And then we have this initiative here from South Africa itself. And that's a collaboration to put all of the National Treasury's data available for us all to look at. And you can see 1,844 open data sets that the government here in South Africa makes available. Some of it is, of course, is just available as PDFs, but you can select there if you want Excel spreadsheets or CSV files. And there's 93 pages of this data. You can see them some XLSX spreadsheets, CSV data files. So for the majority of these, they are data files. And the one that I want to look at is this one, the major infrastructure projects by the national government. And so if you click on that, you can see a sort of little small here spreadsheet of the data and a little bit of information about the data, and show more there at the end, more information about the data. And then one way to get hold of the data is this URL that it gives you here at the top. So you can copy and paste, or what you can do is just right click on it and say copy link address. So in any browser that you use, that should be available to you. So copy link address. And that's going to allow us to import this data set. So let's just do that. Now I'm going to just copy and paste it. I'll move it to my other screen because it's quite a long URL. DF, and we're supposed to call it DF infrastructure, I think is what I called for in the question. And we're going to simply do a pd.read_CSV. And I'm going to paste in that whole long URL. And what you'll see immediately is if you run this line of code, there is going to be a problem because it's encoded differently from UTF-8, which is the normal way that the characters on your computer are encoded. So there is one of these millions of keyword arguments called encoding, and I'm going to set the encoding to Unicode. Unicode is a different type of the way that your computer represents characters. So if I do that, we should import that whole data set right from Open Africa. And so let's have a look.
Yeah. Can you just quickly post that link for them in the chat so that they can try it themselves as well?
Okay, hang on for me. Chat to everyone. There we go. Right, is it up?
Yes, thank you.
Okay, so copy and paste that one in. Let me move this off the screen. And pd read_CSV, but I say encoding UTF-8 is the usual encoding of characters on computers, but this data, Open Africa, for many of the data sets, they use Unicode instead of UTF-8, so you always have to, for most of them, you have to put this under this encoding keyword argument. So view the number of observations and number of variables. Remember, that's just going to be the shape. It's going to show us how big our data set is here, and we see we have 49 rows of data across six variables. And if we just want a bit of info on each of these, remember it's this DF. Oops, I got the wrong one. There is a DF infrastructure. DF infrastructure.shape. I thought there was something wrong there. 294 across 17. So DF_infrastructure, and we want some info on that. So let's have a quick look at that. And we see there's some of them with a bit of missing data there. So you see they're zero non-null. That means all of that data basically is missing, and all of that data is missing. So when you start working with some real world data, you're going to see in the end that quite a bit of it is missing. If you always, when you do these plots, sometimes you can't remember what all your columns are about. Remember, you can always just call the dot columns. Oops, let me just spell that correctly. Dot columns, and you'll just get this index object here, which just shows you all your column headers. So visualize the project per value sector. So if we look at these, visualize the project value per sector. So there we see the sector, and if we go to there, we've got sector, and we seem to have project cost. So project value in rands. So that might be an interesting thing to start to explore. The government, in what sector are they putting their money? So let's have a look at that. Of course, you can first summarize that data, but let's go directly for data visualization, because this is what it's about. I'm using Plotly Express, so it's just plotly.box would be one way to look at continuous numerical variable. So df_infrastructure is the data frame that I'm working with. On the x-axis, we said we wanted the sector, and on the y-axis for our box and whisker plot, we want project. What was it? Project value in rands. And let's just give it a nice title. Let's say a title equals, let's say project value, just to keep it short. And let's do, I'm going to do just this, just to remind you how this works. Let's see what error did we make. Rands. Project value rands. Let's see if there are other errors. No, there we go. And we see where the government spend is, but just at the moment, it's using the variable names in the data set. It's using that as my x-axis and y-axis labels. And of course, we don't want that. And then Plotly Express, we get rid of that using the labels keyword argument, and we pass a Python dictionary. So it says sector at the bottom. So you say the key is sector and what you want it to be replaced with. Let's put an uppercase colon, let's put uppercase sector. And across the y-axis, we had, what is the project value range? Project value range. And we want that to be replaced with, let's just replace that with ZAR so that we can range. There we go. And that's how you change those. And now you see it will say ZAR and sector with an uppercase S. So let's just have a look at this. Where's our government spending its money? Certainly urban development and infrastructure, that seems very low. And when it comes to central government administration and financial services, it seems like they spend quite a couple of billion there. And of course, with these interactive plots, we can have a look at that. So when it comes to social services, for instance, there's only 402 million there. When it comes to the median, when it comes to central government, it is up to 7.5 billion. So that's, very quickly you can look at, start to explore as a data scientist, start to explore, start to understand what knowledge is hidden inside of this data set. One thing that catches my eye is this statistical outlier up here, because if you look at economic services and structure, it seems the median there is 2.46 billion. And then there's these data points way out here of 22 billion. So I might be interested in, let's just explore the data set when it comes to those that are projects in excess of 20 billion. So that'll be DF infrastructure. And what we want is .loc. And what we want is just those ones in the project value range that are more than 20 billion. So that's going to be DF infrastructure, and the one that we want is project value in rands. That's the one, and we want those that are more than 20 billion. So that's 20, 0, 0, 0, and then 1, 2, 3, 4, 5, 6. That should be 20 billion. So let's see, in this sector, in this economic services and infrastructure, or at least let's just look at these that are more than 20, that have the infrastructure, the project value more than 20 billion rand. So how many did it return for us? There's 7 entries, and it looks like the bulk of that money went to water and sanitation. And it went to augmentation of existing bulk water schemes. Let's see, it says there. So we can quickly see where this large amount of money, was spent. And of course, it is in this economic services and infrastructure that we see this. And we see these NAN values. It says not a number. And that's how Pandas, of course, tells us that there was no value was captured for that variable. Summary statistics of the amount per year, because there seems to be this idea of the project value in rands, but when it comes to amount in rands, so there's, we'll have to read up on the data set what the difference between those two are. There we see project value in rands and amount in rands. There's certainly a bunch of zeros there. So whether that was how much they wanted to spend when they had meetings and versus how much they actually spend, I'm not quite sure, but you can read up online, of course, what they meant by that. So just let's have a look at that amount range. So DF infrastructure, and we want to group by, this time we want to group by the financial year. I think the question is, show summary statistics of amount value per year. So financial year, what's the column header there, and we want the amount rands, and we want from that, we want the describe function, which is going to give us the summary statistics. Let's have a look at that. So there we go. We see that we've got financial year 2017, 2018, 2019, 2020, 21, 22. So it's definitely projecting into the future. And it's showing us how many of each of those occurred. And when we look at the amount in rands, we can actually see, they were not all zeros. Otherwise, the mean here would be, of course, 0. So it certainly seems that amount doesn't only refer to the actual money spent, but it's part of the projection value as well. So we'll have to read up in the data set what exactly what they meant by those. So the next question, show a bar plot of the average amount value in South African rands for each year. So once again, this is going to be one of those things that I would do separately first, that I would save those years, 2017 to 2023. So I'd go DF infrastructure, underscore infrastructure. And we're going to go the financial year. And from that, remember, we want the value counts. And remember, that's going to return for us the series object where we want both the values and we want the index. So the years, actually, those are going to be the index. And this time around, I'm just going to make sure that I have them sorted. So I'm just going to do the sort underscore values as well. And then I want that all to be exported as a list. Let's check if that worked out correctly for us, if my thinking was right. Yeah, 2017, 2018, 2019, 2020. Of course, you could have just hand coded that as a Python list to say year equals and put those values. But we wanted those in programmatically at least. So what else can we do? Of course, for each of these, we want the mean value. So let's call those amount means. And let's say DF underscore infrastructure. And we want to group by. Once again, group by. And what we want to group by is the financial year. And what we want is the amount rands column. And what we want from that is the mean. So remember what this, let me stop there. What this is going to return, let me just print it out to the screen, amounts mean means. So remember, once again, that is what I meant by we have the series object. So the index was these values 2017 to 2023. And these are the actual values. So to save them, we actually have to do one more step, in as much as we need to express those as values as well, because we certainly only want the values from that. Now, one thing I will say is that the PX, the express module inside of Plotly, is clever enough for you not to have to do that. It will notice that this is a series object. As I said before, it was designed more specifically to work with pandas. It's going to notice that this is a panda series, and it's got to know when it talks about the values to only look at the values, so that we don't have to extract this, the values specifically. So let's just have a quick look at that. Px dot, let's do a bar chart. And we're going to say what X we saved as the years. And on the Y-axis, we have the amount amounts mean is what we save those as. You can see my typing skills as I get tired is really going downhill fast. So the title, let's just make that average value, because that's what we want. And then let's see what the labels are so we can fix them. What did we say? I saved them as year, not as years. And amounts means. Oops, where did I put that extra S? Did anyone see amount? Amounts means. So let's see in the section there, who can pick up the error that I've made here? Years is not defined. That is because that was year. That's where I put the extra S. Eventually. And there we go. So we can see this idea of this big spend in 2018, 2019, but then down in 2020. So we'll certainly have to explore this data set and see, how often, with these values updated. Was it that values for 2020 still had to be added? But I think what you get from this is the idea that you can get these data sets, they're open data sets. The World Bank has got massive open data sets, but certainly I've explored some of this Open Africa, and there's certainly lots, for various countries in the African continent, lots of this open data sets that you can just download very easily and start to explore some of that data. And some of it might be useful, some of it might not be useful. But what is popping up here is a bunch of questions, and we might want to go out and look for answers to these questions. Why does this graph come out to look like this? Why was 2018 so high and 2019 lower, depending on what that variable actually means? So one thing I would suggest really in the beginning, go find these open data sets. They're all over the internet. Many countries are now putting huge efforts into making data about their country and about their government open for everyone to get access to. And there's certainly great initiatives right in South Africa as well to make much of governmental information open and freely available. If only we took the time just to start to explore that data and start to understand, in this field at least, of the type of data that they are collecting, what is available. Great stuff. I think that's the end of these 3 modules. That's a lot of work to consume and think about this week. As I mentioned before, for me also, it's just a reference textbook. So it's these things that you can refer back to as you start your own journey. Good, that's it.
Thank you, Jan. I guess we have 1 minute left, and I see my computer is going to die, as in the battery is going to fail. So I'm going to close off the session unless there are some last minute questions. If not, we'll see you guys tomorrow at 2 o'clock South African time. Thank you, Emil, as well.
Anything from your side, Emil?
No, it doesn't seem to like too many questions today, which is good. Seems like everyone's paying attention and falling in love with all of the data that you're using and showing everyone.
Thank you, Maria. I see the Q&A session there. Yes, what I want to do is just hope for everyone to be slightly inspired and go find some data. Maybe you're sitting on your own data and just start to explore it. And it's an exciting thing to do.
Great. Thank you so much.
Thank you, Kanchu.
Yeah, thanks everyone. See you guys tomorrow.
Everyone.